we're going to get in, and later, and now is the topic of how to get from we assume something and we play the game with the oracle to we want to prove something and we play the game with the adversary. But so each of them have their game, right? The left-hand side of the implies is assured to us by the oracle, and the right-hand side is proved by us. And they each have their game, right? And in both games, the X's have a Forall, right? And how do you prove a Forall is you have the adversary gives you an arbitrary one, right? So on both sides, the X's are coming from an arbitrary place. And while the Y's are exist. So I have to produce the one example of a Y, right? The difference is here that the X's, it has to be true for all X's. It has to be for an arbitrary X. While here, there only has to exist one, which I can specify, right? And so in some ways, the game are the same. The only difference is who goes first, right? And in this game, in my game, when I come up with the Y's, I already know the X's, right? Because we're playing them in that order. But what about the oracle, right? So here is the notation. The X's are kind of free variables, and you see my Y1 depends on X1 and X2, right? While the oracle's game, she has to come up with Y1 knowing nothing, right? And that makes it harder for her. Similarly, when she comes up with Y2, well, she knows X1, right? So that's how we say here, the X's are free, and this Y is a fixed constant depending on nothing, and that Y2 is some constant depending on X1, right? Everybody see the two different games? And which game are you more likely to win, right? The oracle's game is harder, right? Everybody see that? Because the oracle has to win with less information. So here what we're saying is, if the oracle can win, then I can win, right? And how do I win? Well, I just kind of follow the oracle's lead. I do what the oracle says, right? Now, it is true that when I come up with my Y, I know other X's, right? But I can ignore that if I want, right? I can ignore that I factored, right? Right, so this is just saying these Y's can depend on these X's, but they don't have to, right? A rectangle is a more general thing, but it's still a square. And a function that's not constant is a more general thing, but it could be a constant function, right? Everybody kind of buy that? All right. Everybody warmed up? All right, so now we're going to be doing this game between the two, right? The idea is that the oracle knows how to play her game, right? Because we're proving A implies B. If A is true, we're assuming A is true. So that means if we're assuming it's true, then the oracle has a strategy for winning. And we need to come up with a strategy for winning. And we're going to bounce off the oracle to help us win, right? And last term, well, every term probably since before you were born, I've been teaching 3101. And one of the classic topics is minimal spanning trees. And when I was teaching this last term, it came clear to me that the students had no idea how the game was being played, right? Again, we're dealing with Foralls and exists, and there's an underlying game that they were missing. All right, so on the subway on the way home, I busy made slides for them to teach them the game. All right, and then I copied them over here so that when we got, we could do them too. All right, so let me teach you a little 3101. All right, what is a graph? It's a bunch of nodes with edges between them. You know that. What's a tree? Well, a tree can be either rooted or not rooted. It doesn't matter. This is an unrooted tree, and it has no cycles, right? If it's not connected, it's called a forest, but this will be a connected one. And what does it mean for a graph? Here the edges S forms the graph, right? What does it mean for the purple edges to span the tree? It means formally, it's always good to write down what it means, right? It means for any pair of nodes, there's a path between them, right? So how does the game go, right? How do we understand this thing? Well, the oracle is going to be assuring us that these edges span. And what does that mean? That means you can give the oracle any pair of nodes, right? She says it's true for all nodes, so I can give her my favorite nodes. If I'm the adversary or I'm the oracle or I'm the prover, right? I give her my favorite nodes. And then, right, it says for any nodes I give her, she can construct a path, right? Everybody see how this is a great oracle. That's the kind of oracle you want. You go to the top of the mountain, you say, hey, oracle, here are two nodes. She gives you a path between them, right? Everybody see what we have here? All right. So, so now what we're going to do is we're going to take this set of edges, this tree S, and we're going to change it. We're going to add an arbitrary edge somewhere here between U prime and V prime. And then because we know that there's a path from U prime to V prime already, right? When we add this edge, it creates a cycle, right? And so then we take another arbitrary edge from the cycle and we break and we cut it. All right, everybody see the idea? You add one edge, creates a cycle, you find some other edge in the cycle, you take that edge out, and the claim is it's acyclic again. Why? Because we created one cycle which we broke, right? Now, what we want to prove is that if the original graph spanned the nodes, right? Then our new path still spans the nodes, right? Does that make sense? We can modify this to get a different, maybe better solution, right? All right, so this is what we're proving, right? What we're saying is we want to prove that if the left-hand side is true, then the right-hand side is true, right? And how do you do that? You say, well, as the oracle comes along, it is going to assure you that the left-hand side is true. It assures you that there's a spanning path between any pair of nodes, right? And then I, the prover, need to prove that this statement, which that the new graph, right, the darker purple graph has is spanning, right? Everybody get the game? All right. So, oops, these little arrows I added just as I was running over here. and they're not supposed to be there quite yet. All right? All right, so here, what are we doing, right? What is my, and so if you're writing up a proof, and you will be on the next test, it will be focused on these games, right? On the, I must admit I was in Dominican, and on the plane home, I came up with two questions for you, which I wrote up. And one of them I gave kind of a long, verbose answer. I gave two answers. One which was kind of long, giving a description of what was going on, why we're doing it. The other short, just bang, 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 we do it. All right. So, well, let's see if we can give both here, right? The bang, what's happening, and why we're doing it. And when you're writing the test, you can decide how long you want to write it. All right. So how would this be? On a test, I would say, prove that this left side and gives me this right side. So you would start by saying, let's assume the left side. My goal is to prove the right side, right? And when you say you want to go further, you say, let's assume the left side. Let's pretend we have an oracle who assures us of it, right? And then we need to prove the right side. So we have this oracle that's really useful, and sometimes you might want to dive in, but I prefer not diving into the oracle's help yet, but start with the proving game, right? My goal is to prove this statement. All right, so there's the chart you have seen before, and I just added those arrows to it, which will describe what those arrows mean later. But if you look at this chart, what are we doing is I'm trying to prove this statement, right? So it's the second column, and I'm trying to prove a Forall, right? So if I want to prove for all X and Y, how do I do that? Well, I have an adversary give me an arbitrary one, right? So how do I prove this for all statement? Everybody's getting that? You prove for all by saying, let X and Y be arbitrary values given to me by the oracle. No, sorry, given to me by the adversary, right? And why do I say they come from an adversary? It's because it reminds us that they're worst case, right? They're not random ones, randomly flipped. They're not oracle ones, which were divinely inspired, right? Well, they are, well, I don't know, divinely inspired, but they were inspired by the adversary to be bad for you, right? Everybody good with this? All right. And, oops, yeah, ignore those arrows because as I said, I was adding, in fact, this whole thing here I added on the subway on the way here. All right, so now how does my game continue? Right, my game continues is I'm given this by the adversary. Now I need to produce a path, right? So I say to myself, what is my goal? My goal is to construct a path from X to Y within the S prime graph, right? And now actually let me pause for a minute. See, I have a little subscript for all, and I'm inconsistent when I do that, right? In fact, on the informal test, which I was writing out, you know, all these little subscripts, I'm trying to LaTeX it, it's kind of a pain, right? So do you need to include them? I think if it helps explain what's going on, you can include them. But you don't need to. What function do they have in this case is there's a difference between saying for all X, now that X is kind of a local variable, right? Versus X for all, that's an actual object given to me by the adversary, right? So if you want to put that notation in, it's good. The only place you absolutely have to use that notation is in the formal proof when you're doing the exists to make it not a free variable. All right. Otherwise, we can be a little bit more casual about it. Everybody good with that? All right. Yeah, I need to form this path, but I don't know how. And you see it because I just sort of drew something because I don't know where the path is. Right? I don't know how to find a path through a graph. Right? You know, we learned Dijkstra's algorithm, but we're not doing that here. All right. So when we get stuck, we go to our oracle, right? And the oracle is hopefully she can help us. In fact, let me give you a little hint. Whenever A implies B, it's because the oracle is helpful. You know, I'm not going to give you an oracle that's not helpful. If she's not helpful, then the statement's probably not true in the model you're considering, or true, valid in all models, right? All right, so here she is assuring us of that. So we look up in the little table, it says column, she's assuring us, row, for all, right? She's assuring us that something is true for every X and Y. So if you tell me, hey, something's true for all X and Y, I'm going to say, hey, what about my favorite X and Y, right? So I'm going to, and what X and Y do I have? I have the X and Y that comes from the adversary, right? And that's kind of why I put this little arrow here, and here, because a very typical way that these proofs go is when we're proving a for all, I get it, right? If X is for all on the left side and on the right side of the implies that we're trying to do, right? My for all gives me, the adversary gives me an object, and then the oracle's for all allows me to give her something, right? So I take it, I the prover take it from the adversary and give it to the oracle, right? It's a very natural way. Everybody see that? All right, so that's what happened. Adversary gave us these X's, we give them to the oracle, right? And then what does the oracle do? Well, the left-hand side of this table is assuring, and now she's assuring us something exists. And if you tell me, hey, this thing exists, what am I going to say? I'm going to say, great, give it to me, right? So that's what we do, is we say, we're assured that a path exists, so have the oracle give it to me. And this is, in fact, the exact place where you do need the subscript exists, right? You have the statement that something exists, and you give it a name, right? Everybody get that? Because now it's not a free variable, it's a concrete object, right? In this direction, it was fine because it was probably might have been a free variable the whole way through, right? All right, so now, right, she gives me this path. All right, so let's go back to my job. My job is to construct a path from X to Y, but I'm not doing it blindly, right? I have a path from X to Y already in the old graph, and I just have to change it to be in the new graph. Anybody see? Right here, her path is the orange, right? But the problem with her path is it goes through an edge that we deleted, right? So how do we fix the path? Right? We're going to go the other way around the cycle, right? See, her path went the one way around the cycle, and we go the other way around the cycle. Does that make sense? Everybody good? So that, and so here's this other arrow that what often happens is the oracles exist, produces something, and we use that to produce our thing. Right? Everybody kind of buy those arrows, those yellow arrows? That's usually the flow of information. Everybody good? How many people feel they're kind of getting this game? How many people feel they're still lost? You got any questions you can ask?
Just a good example. What's the assumption and what's the part you're trying to prove? Like you're assuming that S spans S prime, or
No. We're proving that S spans all the nodes, and we need to prove that S prime spans all the nodes. Right?
Assume that S spans all the nodes.
Yes. Okay. Right. So here you see that it's written out in starts off the Forall nodes in blue, right? So that's the statement that S spans, right? It says for any nodes X and Y, there exists a path from X to Y in S. That's what we want to prove.
And the second part is?
Sorry. I lied to you. The first part is what we're assured, we're assumed. And the second part is what we want to prove, that could have been any pair of nodes. There's a path in the new graph, right? So it's going from the old graph to the new graph, right? And so right, so here it's can we just start at the beginning and do the whole thing again? And now you guys who are nervous, if you're nervous at some point, holler, okay? I expect at least one, either at the end of this, you have to say, oh, now I get it, or you have to tell me what you're missing, all right? All right, so everybody get what a spanning graph is? It's a set of edges, forms a tree, given any two nodes, there's a path between them, right? Right? Right, if the oracle's assuring that it spans, then I can give her, anybody can give her a pair of nodes, right? It says all pairs of nodes have the path. So I can give her a pair of nodes, and she gives me a path, right? Everybody get that? Right? Yeah.
So there's like there's these two, there's a line with two nodes on one side, the other, that's called a path. Is that called a path?
Right. So the graph, this is a graph, right? In our spanning tree, actually, there's a bigger graph, lots of edges, and this is a subset of the edges, which is forms a tree. All right, so you see, why is it a tree? Well, it has a bunch of nodes and edges between them, and they don't form any cycles, right? So there are these funny leaves sticking out, and they don't go anywhere. Why? Because if they went somewhere, then you would probably have a cycle, right? You got that? And then the adversary gives two nodes, and she comes up with a path between them. Right? So you see the orange is a path between these paired nodes. Right? Right? What is a path? It's a sequence of edges that gets you from where you're going, right? Does that make sense? Everybody get this part? All right. Right. So, what I'm trying to demonstrate here is that you're trying to prove something that could look complicated. The first step is really knowing how to play the game right, right? In fact, I don't know if you know 3 blue, 1 brown. I always get how many is what. It's a fantastic videos, but I was watching one the other day, and he was trying to prove basically for all X there exists a Y, and in my mind, you know, I hear that that's what he's trying to prove, and so I want him to say let X be arbitrary, and he doesn't. He sort of says let's consider a Y. And when it's what are you talking about considering a Y? Your goal is to construct the Y once you know the X, right? All my bells go off, right? So, you know, you don't want, when people are reading your proofs, you don't want their bells to go off, right? Now, in the end of the 3 blue, right, kind of bring it all back so it worked. And then he said, yeah, we're doing this Y, but what we're doing this Y would work for any X. All right, yeah, but that still makes me nervous, right? Let's not do it. Let's play the game right, right? So, all right, so we changed the graph. Everybody get that? And then, so then in some 3101 class, some calculus class, they tell you prove that if this is true, then this is true, right? But they don't necessarily give it to you as a first order logic statement. And so you don't know how to begin this proof, right? Remember I told you my little brother was taking this hard course and he didn't know how to begin, right? So I said, write it down in first order logic, right? This is the statement. This is the definition of S spanning. This is the definition of S prime spanning, right? Everybody see that? And so what's the game is we want to prove A implies B. So we assume A, and if you like my games, right? I mean, you could do Turlakis' formal proofs, which we're going to get into a bit. But when I see people just kind of doing it, they just sort of hack at it. They don't know where they're going, right? Right? In fact, they might start with the Forall X, and they say, well, one of the rules for all X is you can rip the X off, right? Yeah, but you rip the X off and put what in its place? You can put a free variable there, but really what we want there is not a free variable. One thing, what we want is the X is given to us by the adversary, right? And sometimes if all of them are free variables with the same name, then it kind of goes through, right? But here, in fact, they're not the same name. In fact, to make our life easier, you'll see I gave everybody a different name, right? Here, this is X, this is X prime, right? Now, could I have used X here? Yeah, because it's a free variable. It doesn't matter what you call it. But to help our understanding, we want these things to be different. And if you just ripped off the Forall, then you would have statements here about X. Well, really what we want to prove is statements about X prime. Right? So it's good to know, I think it's good to know the game. Everybody get this part so far? All right. So, what is my goal? What do we do in the proof so far? We set up our oracle. We set up the fact that what we want to prove, right? We say, hey, the oracle assures us of the left-hand side. Our goal is to prove the right-hand side. We set that up, and then we go on to prove our statement. And what does our statement start with? It starts with for all X. So how do I prove a for all X? Well, you memorize this table, right? And it's not, to me, it makes perfect sense. So you don't even have to memorize it. It says if I'm proving a Forall, then my adversary gives it to me, right? So what do we do next? We say, let x prime and y prime be arbitrary values, right? So down here, I put x Forall and y Forall, but you know, I should have put x prime and y prime, right? All right, so now what do we do? Now my goal is to prove that there exists a path. So somehow I have to construct the path, right? You guys good? Right, then I say, I don't know how to construct the path. And when you get stuck, that's when you go to the oracle. The oracle says what? She is assuring you of a Forall. And when she assures you of a Forall, then you can give her anything you want. And what are you going to give her? Well, you're going to give her the values that the oracle gave you, right? And that was good. And so what does she do? She then goes on to assure you that yes, within S there exists a path. And if she assures you that there exists a path, then what can you do? You can say, okay, great, oracle, give me that path, right? Now, how am I doing? Well, I was given arbitrary nodes x and y, and x prime and y prime, and I need to form this path, but to help me, I have this path from the same nodes, right? So now my goal is to construct from this node to this node a path in the new graph. And do I do it blindly? No, I modified the path the oracle gave me. Right? Does that make sense? And that's the end of the proof, right? So we assumed the left-hand side, we proved the right-hand side, and that completes our proof. And that was very exciting. And then, you know, I added these arrows and stuff in order, you know, I put this in to relate. You can see it's kind of overlapping because I added it on the way here. Everybody see that? And these arrows, what was the game? Is I had to prove these. So I gave them to the oracle. The oracle gave me this, which I came down and constructed that, right? In fact, the line I want to prove for all x there exists the p. That's I need to produce a function from x's to p's, right? You give me an x and y, I give you a p. That's what I need to prove. And how do we do it? We go around the square. I'm given an x and a y. I give them to my oracle. Then my oracle gives me one p. I construct another p. Right? Everybody see that? Sort of composition of functions. Right? How are you guys doing now? Anybody, any mystery? Now, I don't know, maybe George can look at these statements and he can think about his formal proofs. But I certainly can't. But I can look at the statement and I can read the game off, right? And as I read the game off, I can say, yeah, that feels true to me, right? I can believe that I can be given an arbitrary x and y, which I give to my oracle, and my oracle gives me a path in the old graph. And so now what do I need to do is I need to take the old path, the path the oracle gave me in the old graph, and produce a path in the new graph, right? And if you go to my slides, 3101 slides just a year ago, it wasn't doing any of this. It would have just said, what did it have? It would have had this, S spans and hence S prime spans. So what do? We take a path in S prime, in S that's spanning, and we have it go around the other way to get a path over here. And I said, that's the end of the proof, right? But did the students really get why that's right? Why is it that we need to modify a path from here into a path from here? All right. Any questions? All right. So, so what are our formal rules? We're going to kind of, we're doing the formal rules informally here. We're not going to get, there are a lot of words on that page, and we're not looking at all the nuances of them. The only real nuance that we care about now is that, what is a formal proof? Is you have these lines of your proof, and if this is a line of your proof, then this could be a line of your proof, right? And if you have a line of your proof that says for all x, you can rip the for all off. If you have a line of proof that says there exists an x, you can rip the exists off. Now, if you have something without a for all exists, you can put the for all exists back on, right? That's what what was that discrete math course 1019 book said, right? But what's the nuance is what's the difference between a free variable and sort of a constant, right? And so what we're saying here is when you rip off the for all x, you can plug in anything you want, right? You have the for all, so the oracle is assuring of it, and you can plug in anything. And then if you have a free variable, you can bring back the for all. But if it's not a free variable, you can't bring back the for all, right? And when you rip off an exists, you don't have a free variable. You have an exist constant, right? Everybody got that? On the other hand, if you prove it alpha for any weird object in here, could be Jeff's uncle's, right? Then you can say, well, then there exists somebody. Who exists? Well, Jeff's uncle exists. Everybody get that? So there's the proof, but let's not go over because we have slides that we're producing it. All right. So let's see how this translates into a formal proof, right? So at the bottom, I write here what up at the top is the statement that on the test I tell you to prove, right? And maybe we'll tell you to do both an informal proof and a formal proof, right? So here's the formal proof. Is it all that different? Maybe it's, I was thinking it was very different, but now I'm seeing more and more, I see it's not different. It's just how you think about it, all right? So what are we proving? Left side gives me right side. I write down in the bottom the conclusion, right? How do I prove an implied statement? Deduction, right? Right? So here we write our deduction goes left side to right side. We assume the left side, and we have to prove the right-hand side, right? Everybody see that? So when I say that the formal proof kind of plays our game, it's not if you do it from the top to the bottom, right? You have to do it kind of like this. All right, everybody get that? Yeah? Here's our formal proof. We assume that we get that. All right. So that's what we're concluding. And we can kind of have our have and need, right? So what we have, we know is true already. That's our oracle. And what we need is what we're trying to prove, right? And what are we trying to prove? Right? We're trying to prove for all, right? So I'm trying to prove a for all. How do I do the for all? the adversary gives me 1, right? And so here, kind of moving backwards, I'm saying the adversary gave me some values, right? And you'll note if I can prove what I need to prove is line 6, that there exists a path between these values that my adversary gave me, right? And if I can prove that, and this x is effectively a free variable, right? And so then my next line 7 could be, well, the x and y are free variables, so we can add the for all, right? Does that make sense? Right? And somebody was telling me the other day, hey, when they learned it, they had different names for these rules, right? There's substantiate, and I don't know what all the names are, right? We can figure out what they are so you can help, you'll know them in the world. But I don't know, add and remove for all seem to be pretty damn concrete. Right? Everybody get how from line 6 we get line 7, right? And in my mind, I'm saying these are free variables given to me by an adversary, right? So now my goal is to prove this for these free variables, right? All right. So now, what is my goal? Is to construct the path P prime, right? How do I construct it? Right? I have to construct it. So I don't know why there's a space in here. I think maybe because we had boxes coming in and talking. But here, line 5 says, what I need to do is prove somehow I have a path P prime, and it does what I want, right? And so you see from line 5, I've showed that something exists. So in line 6, I can say it exists, right? Everybody get that? All right, but I don't know. Yeah, this is why I have this space so these boxes can come in, right? I don't know how to construct the proof. All right, so we go back to our oracle, right? And we play the oracle game. The oracle is assuring us this statement. Well, she's assuring us for all x and for all y, right? And so I can plug in, I can remove that for all. And when I move that for all, I can plug in any values that I want to plug in, right? What values do I plug in? Right? The ones that my adversary gave me, right? So she's proving the for all, right? The prover gives her these values, right? There they are plugged in, right? Now you might say, how does line 2 give me line 3? Well, if I have a for all, I can remove the for all and plug in anything I want, right? I can plug in Jeff's uncle here, right? Anything. So I plug in the values that my adversary gave me, right? Does that make sense? Right, so now we need to now what do we do next? Okay, she's assuring us, up here on the top is things that she's assuring us. And she's assuring us that there exists some path. All right, so what do we do when she says there exists a path? We say, great, give it to me, right? Give me the path. So there, we have line, we rip off the exists. And all we're doing, going from line 3 to line 4, is line 3 says there exists something. And line 4, sometimes when I write line 4, I do it in different ways. Sometimes I say, hey, line 3 told me something exists. Let's give it a name. Let's call it P exists, right? Let P exist denote the object assured to exist in the previous line, right? Does that make sense? Like those words, right? So we rip it off. All right, so now we have line 4 and we need to prove line 5, right? Well, we have P exists. We have to construct P prime. Well, this is the part of the proof that I've been given for 25 years, right? We just say we construct it by going the other direction, right? If we were taking, if we were actually taking 3101 now, we might put more work into this piece, right? But that's not what we're doing here, right? We're doing now here is playing the game. So in this line, you can just say English magic, right? Everybody get that? Any questions? And that's the proof. Most excellent. Now, this is just saying, well, is this, if you think about the game, why didn't I like this at first? Well, I would see these values magically, if I'm reading it top to bottom, then somehow these magically appear. Now, if this was just a free variable x and this was a free variable x, it feels kind of like free variabling magic to me, so I don't like it. But maybe these objects down here have a different name to them, right? And so then when I go from the Forall, when I rip off the Forall here, I'm plugging in something by magic, right? And I don't like to do things by magic. I like to know, I'd like to give you an argument of how do you get from line 2 to line 3, right? And if what you learn is the way to go from line 2 to line 3 is to rip off the Forall blindly and plug in some free variable, it might not line up with what you need, right? So that was my problem with these proofs, right? Everybody good?